Think about your morning. You brush your teeth, wash your hands, maybe fill up a glass of water. We do it every single day without even thinking about it, right? But behind that simple, effortless flow of water is one of the most incredible, totally invisible engineering marvels of the modern world. So let's dive in and trace this epic journey. It all comes down to this, doesn't it? Clean, safe water. It's something we rely on for literally everything. This is so much more than just H2O. It's the absolute lifeblood of our cities, and it gets to us through a system that is almost completely hidden from view.
So have you ever really stopped to think about it? Where does this water actually come from before it gets to your tap? And just as important, where in the world does it go after you're done with it? All right, let's trace its entire path from the very beginning to the very end.
Okay, first up, from nature. See, the journey doesn't actually start in a pipe. It starts with a huge fundamental choice. The very first challenge for any city is figuring out where are we going to get our water. You can really think of it as the planner's dilemma. They've got to look at everything, the landscape, the geology, the climate, to answer that one single question. And believe me, the answer they come up with will shape the city for generations to come. So, broadly speaking, it boils down to two main options. On one hand, you've got surface water, the stuff we can see, like rivers and lakes. On the other hand, there's groundwater. This is the water hidden in these vast underground reservoirs called aquifers, and we get to it by drilling wells. And there's also a third option that's getting more and more popular: harvesting rainwater. It makes sense, right? When those first two sources just aren't enough, we can literally look to the skies to help top up the supply. But here's the thing. It's not just about picking one. It's a real balancing act. To make sure the system is sustainable for the long haul, planners often shoot for a kind of ideal mix, something like 70% from surface water and 30% from groundwater. Why? Well, it's all about preventing us from overdraining any single source. And trust me, it is never an easy choice. Each source comes with its own complicated set of pros and cons. You've got to weigh everything. What's the cost? What's the risk of pollution? How much water is actually available? And how far do we have to move it to get it to the city? All right, that brings us to part two, the Great Water Highway. So once the source is locked in, the next massive job begins: building this incredible hidden highway to get all that water from nature into the city. This part of the journey basically breaks down into four key stages. First, you've got to collect the raw water from the source. Then, powerful pumps kick in to give it the pressure it needs for its trip. Next, and this is a big one, it's treated to make sure it's safe. And finally, it's supplied to that huge network of pipes waiting under our streets. And let's just pause for a second on that treatment step, because it is absolutely critical. This is where a whole lot of science happens to turn that raw water into safe drinking water. We're talking about processes like coagulation, filtration, and disinfection, all designed to pull out impurities and kill any nasty pathogens. There's this great way to think about it. The pipe network is like a hidden water highway, the city's circulatory system. And that really hits the nail on the head, doesn't it? Underneath our feet is this massive, branching network of pipes, and it's carrying the lifeblood of the community to every single home, school, and business. And just like our road system, this water highway can have different layouts. Engineers have a few designs to choose from. There's a branching tree system or an interconnected grid system. You might see a circular or ring system, or even a radial system that fans out from the middle. Each one has its own pros and cons when it comes to things like water pressure and reliability.
Okay, section 3, the final mile. The water has made it all the way across the city. Now we're zooming in on the final crucial leg of its journey, getting from that main pipe under the street and into your building.
So how does it actually get from the city main all the way up to, say, your top floor shower? Well, it's usually one of two ways. You have your gravity feed systems, which use a big tank on the roof and just let gravity do all the work. Or you've got pressurized systems, which use pumps to make sure you get strong, consistent pressure at every single faucet. Now here's where this whole journey gets really personal. Check out this number, 1,077 liters. You know what that is? That's how much water is wasted every single month from a tiny leak of just 120 drops a minute. It's a staggering amount, and it's a huge reminder of just how precious this resource is and how easily we can lose it. All right, on to our next section. Down the drain we go. So we've used the water, right? We've washed the dishes, flushed the toilet, but the journey is not over, not by a long shot. In fact, a whole new journey is just about to begin. This is really the second half of the story. The water, which we now call wastewater, has to be collected, transported, and treated all over again.
This whole process has to happen before it can be safely returned to the environment. So, inside a building, this reverse journey happens in one of two main ways. You've got a one-pipe system, which is pretty straightforward. It combines all the waste into a single pipe. But then you have a two-pipe system. This one separates what we call black water, that's the stuff from toilets, from the gray water, which is all the other stuff from sinks and showers. And doing that can be really, really useful for water recycling.
Okay, so once that wastewater leaves the building, its pipe connects into a much larger public sewer. And these sewers generally come in three main flavors. You've got sanitary sewers, which just handle waste from buildings. Then there are storm sewers, which are only for rainwater runoff. And finally, you have combined sewers, which, you probably guessed it, handle the whole shebang.
And no matter the type, all of these sewers lead to one final destination, a sewage treatment plant. You can think of this place as the mirror image of the water treatment plant we talked about earlier, but instead of taking things out to make water drinkable for us, this plant takes pollutants out to make the water safe for nature.
And this is the final goal. The whole journey is only complete when that water meets really strict environmental standards. That means they're measuring for pollutants like BOD, that's biochemical oxygen demand, which is bad for fish and other aquatic life, and also FOG, which is just a simple way of saying fats, oils, and grease. Only when the water is clean enough can it finally safely rejoin the natural water cycle.
So think about that. From a river or an aquifer, through a hidden highway of pipes, right into our homes, and then all the way back out to be cleaned and returned to nature. It's this constant, incredibly complex, and absolutely vital cycle. Which kind of leaves us with one big question, right? Since our cities and, well, our entire lives depend so completely on this invisible journey, what can we do to help protect it?